This is section 3.4. We are solving equations with multiple steps. So my first example, 2x minus 3 equals 15, and my goal is to find the value x that satisfies this equation. So we want x to be alone on the left side of the equation. So we need to eliminate first the constant and then the coefficient. And we're going to use addition or subtraction to eliminate a constant. And we're going to use multiplication or division to eliminate a coefficient. So the first thing I'm going to do here on both sides of the equation is add 3. So that gives me 2x is equal to 18. And then I divide by the coefficient 2. And my solution, x equals 9. And now I want to check my solution by substituting 9 into my original equation for x and making sure I get a balanced statement. So I have 2x minus 3 equals 15. So 2 times 9 minus 3 equals 15. So 18 minus 3 is 15. And so I get 15 as my balance statement, which means that my solution is indeed x equals 9. My next example, I have 22 equals negative 3c plus 10. So I want to find my solution, and I want to find the value c that satisfies this equation. So this time I want c alone on the right side of the equation. So I'm going to eliminate the 10 by subtracting 10 on both sides of the equation. So 12 is equal to negative 3c. And now I'm going to divide both sides of the equation by the coefficient, which is negative 3. And 12 divided by negative 3 is negative 4. So my solution is negative 4 equals c. And I'm going to check my solution by plugging it back into the equation. So 22 equals negative 3 times c, which is negative 4, plus 10. Negative 3 times negative 4 is 12, and 12 plus 10 is 22, so it balances. Next, I have 14 equals y divided by 2 plus 8. So I want to get the y alone on the right, so I want to eliminate the constant and then the coefficient. So first I will subtract 8 on both sides of this equation. 14 minus 8 is 6. 6 equals y divided by 2. Since they divide by 2, I will multiply both sides of this equation by 2. So I end up with 12 equals, and these 2's cancel, and I have y. So 14 equals y over 2, so that's going to be 12 over 2 when I substitute my solution in for y. So 12 divided by 2 is 6. 6 plus 8 is 14. And it checks. Now I have a linear equation that has variables on both sides. So you have 4x plus 5 equals negative 2x minus 13. I want to find out what x is equal to, but I have x's on both sides of the equation. So I'm going to take a first step here and work with the variable amounts, and I get to choose, but I either need to eliminate 4x from both sides or negative 2x from both sides. And it doesn't matter which we do. I'm going to go ahead and do it both ways so you can see that we get the same solution. So I'll start by eliminating 4x on both sides. So minus 4x minus 4x. So I have 5 equals negative 6x minus 13. Now I focus on the right to get the x alone. I'm going to add 13 onto both sides of the equation. So 18 equals negative 6x, and then I divide by the coefficient negative 6, and negative 3 equals x is my solution. Now I'm going to repeat this, taking 4x plus 5 equals negative 2x minus 13. And this time my first step is going to be to eliminate the negative 2x. So I will add 2x on both sides of the equation. So I have 6x plus 5 is equal to negative 13. And focusing on the left, I'm going to subtract 5 from both sides of the equation. 6x equals negative 18, and dividing by the coefficient 6, x equals negative 3. So now I'm going to go ahead and check my solution by plugging it into the original equation and making sure that my value x does in fact equal negative 3. So I have 4x, so that's 4 times negative 3 plus 5 equals negative 2 times negative 3 minus 13. So here I have negative 12 plus 5, or negative 7. On the right I have 6 minus 13, which is also negative 7. So my general procedure for solving a linear equation: first, we simplify expressions on both sides by clearing parentheses and combining like terms. Next, use the addition or subtraction property of equality to collect variable terms on one side of the equation. Next, use the addition or subtraction property of equality to collect the constant terms on the other side of the equation. And finally, use multiplication or division property of equality to make the coefficient of the variable term equal to 1. We'll check our answer in the original equation. So here I'm going to simplify the expression on the left by clearing the parentheses, and I'm going to use the distributive property multiplying twice. So I have 2y plus 20. And on the right I have 8 minus 4y. So I'm going to work with the variable term, and I will add 4y on both sides of the equation. So 6y plus 20 is equal to 8. So I'm going to subtract 20 on both sides of the equation. 6y equals negative 12, and I divide by 6, and y is equal to negative 2. Now I'm going to check my solution. So I'm going to plug negative 2 into the original equation where I see a y. Now I don't use the distributive property to do the check, and here's why. I have 2, and I replace the y with negative 2 plus 10 equals 8 minus 4 times negative 2. So because I can do what's in parentheses, I don't have to distribute. So I have 2, and negative 2 plus 10 is 8. So I have 16. And on the right, I start with the multiplication. So I have 8 plus 8. And so I get a balanced statement, 16 equals 16. In example 6, I have 3 terms on the left side of the equation, and I am going to combine the like terms. So 2x plus 3x is 5x plus 2. And on the right side, I'm distributing, and I have negative 12 plus 4x. So it's going to take 3 steps to solve this equation because I have variable terms on both sides. So I'm going to start by subtracting 4x on both sides of the equation. So I have x plus 2 equals negative 12. And I will subtract 2 on both sides of the equation. And x equals negative 14. When I check this one, I end up with negative 68 equals negative 68. So I'm going to do 2 times my solution, negative 14, plus 3 times negative 14, plus 2. And on the right, negative 4 times 3 minus negative 14. Okay, so this is negative 28 minus 42 plus 2. Negative 70 plus 2 is negative 68. And on the right, I have negative 4 times 17, which is also negative 68. And here are some for you to try.